All right, so now let's go over to what a deterministic finite automata is. All right? So there it is. For every state that this machine might be at the top of the loop, right, ignoring, like here we have this local variable c, but we don't have it at the top of the loop, right? So at the top of the loop, what are the various states we might be in? Well, here we might have various lengths, and we might have various values for r, even or odd. And so each of these is a state. It says I have length 2, and I have r is even. I don't understand what you're saying at all. You want to try again? What's the...
So like the first pass, right?
Yeah.
L is
0.
You read a character.
Then it's 1.
But you don't increment it plus 1. You're first checking if it's less than 4. So every time you keep going through, your length is technically less than the actual.
Yeah, so when it's 0, I go to 1, then when it's 1, I go to 2, and then I go to 3, and then I go to 4, and then once it's 4, I'm not allowed to make it any bigger.
Well, once you read the 4, what's it like?
Then it's going to be 4 forever.
Okay.
Right? That's kind of, there I'm using 4. Here I'm using length is greater than 3. All right? So I just can't remember arbitrary lengths. So I'm just remembering lengths up to 4. Right? And you can see now what does this graph do, right? If I'm in this state where my length is 1 and my r is even, and if I get a 0, I make the length 1 bigger and I don't change r. And if I get a 1, I make the length 1 bigger and I change the r from even to odd, right? Where do I start? I start with length 0. That's this guy. That's the start. And I start length 0 even parity, right? And the woman in the front said, once my r is my length is too big, I no longer need to remember the parity, right? So here we had this extra thing that once it's too big, we say we're dead and we'll be dead forever. Right? And when do we accept the double string circles? Right? Is if the string ends and I'm here, then the length is 3 and it's odd parity, so I accept. Right? In fact, for any length less than odd parity, I'm accepting. Right? Does that make sense? So, right, we build a state, we build a node for every state the machine might be. Every set of the values. This is just like we did when we had a Turing machine. Yeah?
What do you mean by accepting and rejecting? Does it hold?
When the machine is done, when you've read in the whole thing, it stops, and if you're in a double circle, then you say yes. If you're in a single circle, you say no. And yes means the string I read is in the language, and no means the string I read is not in the language. Right? Yeah? All right, when you've read nothing, this little arrow tells me I'm going to start here. And that tells me the length is 0 and there's even parity, right, which we set the code up for up there. Right? And if that's the end of the string, then is it going to accept the empty string or reject the empty string? It rejects the empty string. Why? Because it doesn't have odd parity. Right? In fact, this node, so a lot of people point out, you can't get to this node. Right? So we could delete this node from the graph because you're never going to get there. I just put it in there to show you the pattern better. Right? Everybody following this? Right? And I want to give, just like with the Turing machine, I want to give states meaningful names. Right? Now, I didn't label each one, but, the implication is that these are the, what's the name of this? Is length 0 even. Right? So that's a good name. Somehow, when you're doing this on a test, every state needs a good name. Sometimes I write it in here, what my good name is. Right? Does that make sense? And, right, that's when we have the various lengths. Here we have the various values of R. And now the temporary variable doesn't need to be considered because we're just talking about where we are at the top of the loop. Right? And then the start state is initiated at the beginning. Right? And then what does the code do? You have to say, what you have to do is for every state that I might be in, I run the whole loop, and I say, well, where will I be if I've read a 0? Where will I be if I read a 1? Right? Does that make sense? And just like on the midterm, right? I just said line 1, and I didn't give lines to the other guys, right? And I kind of hinted, keep going until you move the head. Well, you move the head at the bottom. So you really only need one step, right? So all of this, in this case, you might notice that I haven't mentioned the line number yet, all right? And here we're not going to have any line numbers. Well, maybe it's assumed we're always at the top of the loop, right? So you're at the top of the loop, and then you execute all this code. I don't care what's happening. And in one iteration, you only read one character, right? So after that one character, I want to know what state I'm in when I'm at the top of the loop, right? So that's why we don't say what line number we're in, because we're always at the top of the loop. People following that? You look like you're not following it. Do you have a question? No, you're good? All right. Sometimes. All right, so here, how do we define a Turing machine? Exactly like DFA is just like a Turing machine without a tape, right? So it's a delta function. This is the state I'm in. This is the next character that I read. And this tells me what state I'm going to be in next. Right? We don't do anything about tapes because we don't have a tape. Right? So that is how you define a DFA, deterministic finite automata. And then when you accept, well, if on all these states you accept because the length is less than 3 and the parity is odd. Right? So we do those double circles. And then sometimes it's nice in your DFA to have a dead state where you go there, and I often call it the dead state, and there, once you're there, you just read in the rest of the busy loop, reading in the rest of the input because you know the answer is no. Right? Sometimes I have a yes state where I just busy wait and read the rest of the characters, and because I know the answer is yes. Yeah?
Why don't we pause when you go to the dead state?
Because the formal definition is you have to keep going until the character is read. So it's just busy waiting, reading in the rest of the string. Right? All right, so now I think we're doing pass through it. Right? So if you have a string, then what is it doing? It's following a path through this, right? And it gets to that node, so it accepts. Everybody buy that? And here's another example, right? We follow a path, and then we reject, right? So this is just seeing that what a computation does is it follows these paths.